In the last video, we talked about variables, but variables aren't that exciting unless we can do some operations with them, which we were kind of doing in some of those examples here, but I want to kind of more explicitly lay out the arithmetic operators that we have at our disposal in the Arduino environment. So, operators are basically just some way of computing and manipulating variables. A lot of this information is going to translate from what you've learned in your math classes, but in Arduino, we have basically kind of four main categories of operators. The arithmetic operators, the logical operators, relational, and bitwise. Right now, we're just going to focus only on the arithmetic operators. We'll tackle those other ones later. But yeah, so we are going to use some variables, which are, those named values, literals, which are just what we call the values that we're hard coding in the program, and operators, which are what we're learning about here, to form expressions which will compute to values, and then we can make complete statements, which is a complete line of code inside of the program. So yeah, like I said, an expression is just some combination of literals, variables, and operators that computes to some value. So it's kind of a sentence fragment. It's not a complete chunk of work in the program. It's not a complete line of code, but it's just a little snippet here, right? So a plus b, c times 11, these would all produce some value, but it's not a complete line of code. It's not a complete statement. So this is just an expression or a fragment. But then to have a complete statement, it represents, an entire instruction that the program is able to complete. It's got to end with a semicolon, and it's kind of like the atomic chunk of work within a program, right? So here we can kind of see some of the stuff that we borrowed from the previous slide, where we just said b plus c, but now what we're doing is we're assigning that sum to a. So it's doing some work. It's a complete statement here. All right, so here are the operators that we're going to be talking about, right? So I'm going to define them kind of in terms of their function and their precedence. Right, so the function is just kind of what it does, and the precedence is its order of operations. So just to kind of rehash this, the assignment operator is not an equal sign. It's not saying these two things are equal. It is forcing the right-hand side to be assigned to the left-hand side, right? So there can only ever be a variable on the left-hand side, and we're just assigning those values across the equal sign. So here are our arithmetic operators, and kind of arranged in the order of precedence, with the highest precedent at the top and the lowest down at the bottom. And what you see here is it's essentially PEMDAS, right? We don't have exponentiation. There's another way of approaching that, which we can talk about later. And then there's a weird special additional operator in here that we'll talk about. But from what you can see, it's basically kind of the same of what you would expect from a math class, right? So parentheses we can use to kind of force some precedence. Then we have like our multiplication and division. One important thing to note is that multiplication is done with an asterisk in programming as opposed to an x, because if I said xy with x as my multiplication symbol, it would get confused. So we use an asterisk here. For division, it's a /. And then there's this new operator here, modulo, which is used a lot in programming, but isn't really talked about classically in a lot of math classes. And so what modulo does is it essentially gives you the remainder of a division operation, right? So if I take 15 and I do 15 modulo 4, what it would do is it would divide 4 into 15, which goes in 3 times, but there is a remainder of 3. So it would just give me that value of 3. That was a poor example because both the division and remainder portions were 3, but that's how it works. But yeah, if you went here 13 mod 4, it would produce an answer of 1. So yeah, again, order of operations would be parentheses, multiplication, division, modulo, and then addition, subtraction, which would work the way you would expect it to. So let's go through this example here, kind of pretending that we are the Arduino and we're doing these calculations. So the nice thing is that oftentimes we're just kind of outsourcing the actual calculations to the Arduino. We don't have to do it, but we're doing it here for the sake of this example, right? So we're kind of starting with these variable declarations right here and these initial values, where x is some integer value of 5 and y is some integer value of 6, right? So x can only store integer values and y can only store integer values. So if we were going right here and we said x equals x plus 4, we would take that previous value of x, which is 5, add 5 plus 4, so x is now 9, which is pretty similar to the last example we did. And then we would substitute that value of 9 in here, and we would say it's 9 plus y, which is 6, and so x is now a value of 15. And then here we would say, okay, x is equal to x divided by 5, so we would say 15 divided by 5 is 3. And then we substitute that value 3 in here, so it's 3 times 7 is 21, so x is now 21. And then we say, okay, 21 mod 5. So 5 goes into 21 4 times, but we only care about the remainder for modulus. So our answer here is 1. And then here what we're doing is we're introducing a new variable. We're declaring a new variable that is a float, and it has some value of 2.5. So in this expression here, I'm taking the previous value of x, which was 1 from this statement, and the value of z, which was 2.5 here, and I'm adding 1 plus 2.5. And so you might think that that would give us 3.5, but what happens is x can only store integer values. So the Arduino isn't going to complain, it's just going to drop the decimal point. So it's not going to say, hey, that's 3.5, we would typically round that up to 4. All it's going to do is drop that decimal point and just make it 3. It doesn't do any sort of like formal rounding, it just drops off that decimal point entirely. So x would be a value of 3, and then here for this last one where I'm taking z and I'm adding x plus the previous value of z, which was 2.5, I'm taking 3, I'm adding 2.5, I get 5.5, and because z is a float, it can represent the decimal point, so it would get its full value of 5.5. And yeah, it looks like we did it correct.